Hey everyone, Mr. Skelton here, back at it, starting lesson 3 in unit 6, and today we're going to continue our review of geometry skills in our trig unit, trigonometry unit, and today we're going to be talking about vectors. My guess is in your geometry class you covered some of the basics of vectors, and we're going to do the same thing here. We're not going to get too crazy with vectors. You're going to do a lot of vector work when you get to your trig class next year, but this is just good to reacclimate yourself to vectors. And to be honest with you, all vectors really are is just right triangle trig. All you're going to be doing is working with a right triangle, finding angle measures, finding sides, things that you've already done. This is kind of like, I like to explain vectors in a way, it's like it's an association. It's something that you can associate and apply. I say association, application. It's more of an application of your right triangle trig work. And so you're going to see a lot of things come into play that you've done in lessons 1 and 2, and we're just going to apply them to some new terminology maybe with vectors, but that's really all we're doing. So let's just jump right into it. Let's talk about really what a vector is. A vector by definition has both a direction and a magnitude. So a vector is like a boat. It's usually used with like a boat or a plane, where there's a speed and a direction are the two most common things. So when we say, most people are good with direction, so we're going to be talking about, north, south, east, and west. And then magnitude is something that has size. So a lot of the times it's speed, okay, when we're talking about how fast a plane is going. Your magnitude is usually this distance from basically point A to point B, okay? You have what's called an initial point, and the initial point is essentially where you start, okay? And a lot of times that's the origin. And you have what's called the terminal point, and that's where you end, or you finish. And the distance from the initial point to the terminal point is your magnitude. 30 miles an hour. You're traveling along this path for 30 miles an hour. Now the direction we'll get into here in a little bit. So really what's going on here, and I don't want to put too much on this picture because I think we're going to get into it on the next one. Yeah, we'll get into the next one, so we'll kind of explain it here a little bit more as we go to the next one. Okay. So that's what a vector is. This is a vector. One thing I also want to point out is it always ends with an arrow at the end. There's always an arrow here. There's a small one on your notes, but it's hard to see. Okay? And we're going to figure out as we go through this the coordinates of this. And it's not, you don't use parentheses. This is called, I'm going to draw an arrow because I'm losing space, it's called component form, or component coordinates, and they're kind of V's, sideways V's, and it's X, Y, okay? What's really happening here is, I'm putting dotted lines here, but this is your coordinate plane, okay? So this is your north, this is your south, here's your south, here's your east, and here's your west. A lot of the times, most of the time, what we're going to be dealing with is coordinate vectors, so it's going to be on the coordinate plane, but we go north, south, east, west, and you can see X and Y because this is your X distance here, left and right, and then this would be your Y distance up and down. We're going to talk about that more on the next page. But any vector we can slap on the coordinate plane, and that's how we get our direction. We're going to talk more about direction here in a second. All right, so that's some of the basics, some of the terminology. So on this slide here is kind of what we're kind of talking about here. We talked about this already with the components. So again, I'm going to put north, south, east, and west on here. North, south, east, and west. Okay? And we have what's called components on a vector, and what we kind of talked about here. We have a horizontal component, which is your X. And we have a vertical, which is your Y. And that should make sense, right? Because this is, I know this, I put east here, but this is still the X-axis, which runs left to right. And your Y component runs up and down. So it's still your Y-axis, okay? So the tip of the arrow is our component form of x comma y, because you go to the right 1, 2, 3, 4, 5, 6. So 6 comma 1, 2, 3, 4, 5. 6 comma 5 went to the right 6 and up 5, and that would be your component form of the vector. Okay. Now, one thing we haven't talked about yet is our angle. Now, most of the time when you want to find an angle, we use the theta symbol. That's an unknown angle. It's very common in geometry. And so that represents theta. What you see here, and this is really, really important, from the onset I told you all this is right triangle trig. And what I want to point out to you is that your vector, which I just highlighted, it says original vector, is basically made up of your horizontal component and your vertical component. And if you look at what I just drew, you have a nice, good old-fashioned right triangle. If you go back to the first page here, you can see when I did my north, south, east, and west, if I bring this dotted line, if I just draw a solid line here, look at my right triangle. And now I have Pythagorean theorem in play. I have my sine, cosine, and tangent, opposite over adjacent stuff, and that's what we're going to be doing to find certain parts of your vector, okay? So, again, back to this slide here. One thing that I want to point out to you, and I kind of pointed out later on, but I'm going to emphasize it again because this is going to help when we get to our next lesson, which is lesson 4, is what makes up your horizontal and vertical. Not only is this x and y, but you can set it up a different way. So this angle right here in terms of direction, this is going to be this direction right here, this theta angle. I'll just make something up. I'm going to put 35 degrees. Okay. So when we talk about a vector, it's going to say this vector would be 35 degrees north of east. Because this vector is going from here to here, this angle is right here, 35 degrees, and the vector itself is above the east, so it's 35 degrees north of east. Now there is another way you could name this, right? Because this is a right angle. So if this is 35, then this would be 55 degrees over here. So you could also describe this vector, the original vector, 35 degrees north of east, or you could say what? You could say 55 degrees. What would it be? It would be east of north. You could also say it that way. Either one works. So this is, when we do this, we're talking about the direction. When I ask for the direction of a vector, that's what I'm asking you for. Okay? All right. Let's jump down into a problem and try to start putting this all together. This says find the vertical and the horizontal components of the vector. All right, what does that mean? That means we're always going to use a right triangle here. And again, if you want to put in your north, south, east, and west, you can. You have your north, right? Here's your south, here's your east, here's your west, okay? And you need to find x and y, okay? Now, we know the vector is 5.7 miles, okay? This distance is 5.7 miles. That's our vector. And it's 26 degrees north of east. What we want to try to do is find the component form of this vector. So we're going to use our right triangle trig that we used before. So if I want to find my y, here's 26 degrees, so I have opposite over hypotenuse. What's opposite over hypotenuse? That's sine. So it's sine of 26 degrees equals opposite y over the hypotenuse, which is 5.7. Okay? And so all we do is to find our y is we're going to take sine of 20, get my calculator in here, move this over just a touch. We're going to go sine of, because we're going to cross multiply here, right? So y times 1 is y. Sine of 26 times 5.7. And I get y equals 2.49. Okay? So that's my y value, found my y. Now if I want to find my x, how do I find my x? Well, here's my x, here's my angle. So x would be the adjacent side. It's touching 26. Adjacent over hypotenuse is cosine. So cos of 26 equals adjacent x over the hypotenuse, 5.7, cross multiply. So cos of 26 times 5.7 equals. Now, if you're using your graphing calculator, remember, you want to be in degree mode. So if you're not in degree mode, you want to make sure you're in degree mode on your calculator. You can see it says DEG on my scientific. Remember, your graphing calculator is its factory settings are radian mode, so you got to hit your mode button, go down to degree, and hit degree. Okay, so find the vertical and horizontal components of this vector. So if I ask you to put this in component form, name this point, that would be your x is 5.12, comma, 2.49. That would be component form of your vector, okay? And that would be your answer. Now, one thing that I want to point out to you, and this is going to help you with Unit 4, which is the unit circle. The way you find your x value always is always cos, okay? Cosine of the angle. So this is always going to be cosine of theta times the magnitude. I'll put m. To find your y, it's always opposite over hypotenuse, right? Anytime you find a vertical distance with a right triangle, you're going to have opposite over hypotenuse. So to find your y value is always sine times theta, sine times, right? Sine times 26, theta is the angle measure, times the magnitude. And that is how you find the components, okay? And so I'm showing you that because this is what you're going to remember for the unit circle. Your x value is always the cosine of theta times the magnitude. Your y value is always the sine of theta times the magnitude, okay? All right, let's turn it over here. Now I have a couple more examples. This is kind of tough to read, but you can kind of see it. What I'd like you to do is find the vertical and horizontal components for A, B, and C. Now, on this one here, here's vector A, here's vector B, and vector C is straight down. You kind of miss it there. And again, what I'm asking you to do is what I just got done doing. Now, you can do it either way. If you want to set it up as sine and cosine and do the cross multiplying, you can. Or if you know now that every x value is always going to be adjacent over hypotenuse, you can use your cos of theta times m or sine of theta times m to find this. So on this one here, I want you to hit pause, and I want you to just try it and see what you come up with. Okay, so I'm going to drop this down, okay? And again, we want to find the components, or the tip of that arrow, the components of this vector. So here's 28 degrees. You're always making right triangles, always. And you have, what is that, 66? So your vector is 66. It could be miles, it could be feet, it could be whatever. And you want to find x and y, okay? So again, if you're finding x, anytime you want to find your x, that's adjacent over hypotenuse, which is going to be, I know that all I need to do for A is take cos of 28 degrees and times it by my magnitude, which is 66. And for my y's, it's always the sine, right? Because here's your angle, opposite y over hypotenuse is always going to be your y value, because there's your y right there. That's your vertical component. So sine of 28 degrees times 66. So now let's just simplify that. So cos of 28, cos of 28, I always like to hit equals first, and then I times that by 66. You got to be real careful how you put that in your calculator. So 55.27, comma, and then again, watch how I put this in my calculator. Sine of 28, close the parenthesis. So you're taking the sine of 28 and then times that by 66. Otherwise, you're going to get something crazy. 30.98. Okay? And so this would be that would be your answer for A. Let's do B. B is a little different. Now here's why. When you go to make your right triangle, okay, you have 60, does that say 66? Ooh, boy, I can't read. I think it's 56. Just covered over my own. Yeah, it's 56 degrees. So this is a 56 degrees. 5, 6. And you have 40 as your magnitude. And you want to find that point. All right? So again, you want to find the x and the y. Okay? And now we want to do it. We want to do it, right? So if you want to find your x, it's going to be the cos of theta, which is 56 degrees, cos of the angle times the magnitude, which is 40, comma, and we want to do sine of 56 times the magnitude, which is 40. So we just take cos of 56, times that by 40, and I get 22.36. Now, here's where students are going to make mistakes. Notice the quadrants. This is quadrant 1, this is quadrant 2, this is quadrant 3, this is quadrant 4, right? We have to obey our positive and negative rules in our quadrants. Like this point right here is going to be positive, positive, because your x value is positive, your y value is positive. For vector b, this distance to the x is negative because you're going to the left. So even though my calculator says 22.36, my final answer for this component form vector is going to be negative 22.36 because I'm going to the left. Now, when my y, I'm still going up. So when I go sine of 56 times that by 40 and hit equals, that's still a positive 33.16. And that point should be negative 22, 1, 2, 3, 4, 5, 6, 7, all the way to 22, and then up 33.16 because that's positive. Okay? So you got to be careful when you have positive, when you're in quadrant 2 and 3 and 4, you got to be careful of your negatives. All right, C is nice because they're telling you that this is 46.8, and since it's not going off of the coordinates or the axis at all, this is just going to be 0, comma, negative 46.8 because that's that distance. That distance is 46.8, and that's all you would do. There's nothing else to do there for that vector. Now, the one thing I do want to add to this is direction. So this 28 degrees, let's describe this vector. 28 degrees, that would be 28 degrees, what? That would be north of, if you go north, south, east, and west, this would be 28 degrees north of east, okay? This right over here is 56, so that would be 56 degrees, what? North of west, north of west. And that's describing the direction of those vectors, okay? We wouldn't have anything here because there's no degrees. We'd just be going straight down, okay? It would just be south. We'd just be heading straight south, okay? Straight south. This last slide here is really what we've already been doing. So it's just to emphasize this again. If you were to, if I was to put in my axes here to make it look like what we've been doing, the whole point of this slide is just the reminder that if you want to find your x distance, which is on the x-axis, it's your magnitude, just using some different letters so you can see A is the magnitude. So it's just the same thing we were doing. It's whatever theta is, cos of that times A to find your sine, or to find your y coordinate, right? It's always going to be sine. So again, it's this. It's cos, I always write it this way, cos of theta times your magnitude, comma, your sine of theta times your magnitude. And that is how you find your components, okay? On the back here, so now we're just going to do things in a different way. We're going to kind of go backwards here. So I'm going to do this first one here with A. So I'm going to put this here, and I'm going to put this here. So my north, south, east, and west. All right, and it says find the direction and the magnitude of the following vectors in A and B. So right now, here's your right triangle. You're basically 10 and 5. You got to find the magnitude. So anytime you have to find the magnitude, I just say use Pythagorean theorem, right? So on this one here, we're going to go 10 squared plus 5 squared equals r, since I have r there for the magnitude, r squared. So that's 100 plus 25 equals r squared, right? And so it's 125 equals r squared, and we take the square root. Now, you don't have to break stuff down. You can just go second square root, 125, hit equals, you get 11.18. So that would be our magnitude, okay? Now, it also says the direction. So that means you have to find theta. If I put theta right there, you have to find that angle. Well, you know that from what we did in lesson 2. So I would just go opposite over adjacent, which is tangent. So I'd go tan of theta equals opposite 5 over adjacent, which is 10. So remember, we're finding the inverse, right? We're going tan -1 both sides, tan -1 both sides. To cancel out my tangent, I get theta, or the angle measure, and I just go second tan, because I'm finding an angle measure of 5 over 10. I just hit equals, and I get 26.5 degrees. Now, to get the degree, that's one thing, but now I need to describe it. So what is this? It's 26.5 degrees west of north, right? It's going to the left. You always start on, this is kind of tricky. When you're doing the direction like west of north or north of east or south of west, whatever, you always start on north, south, east, or west. So I would like start here and then go to my vector to the left. So I start on the north, I'm going left because I'm creating this angle, so I'm going west of north. That would be there. Okay? All right, I want you to try B on your own and see what you come up with. All right, so you basically have, here's the arrow down here, right? So you kind of follow the arrow. So if the arrow is here, that means you started here. So if you're drawing your XY axis, it would look something like this, right? There's north, there's south, there's east, and there's west. And here's your right angle right here, okay? And we're going to find theta here. So the first thing we need to do is we need to find our magnitude. So 30 squared plus 40 squared equals r squared. So this is kind of nice because you can do it all in your calculator if you want. Watch, you can go, get my calculator in the view, you can go 30 squared plus 40 squared, hit equals. We know we got to take the square root of that, so square root of the second answer should get 50. So that means r equals 50. So that's our magnitude. So you know that's 50, and now we just got to find this angle measure. So I'd go opposite over adjacent, which is tan, right? So opposite over adjacent. So I would go tan theta is opposite 40 over 30, okay? And I'm going to tan -1 both sides. You don't have to do this part. It's out of habit. Tans cancel out. You're just left with theta equals, and then it's inverse tangent. So second tangent of 40 divided by 30, it equals, and you get 53.13 degrees. Okay? And then you have to describe it. So when you're describing that, again, you always start on north, south, east, or west. You never start on the vector. You always start on north, south, east, or west. Right? If you started on the vector, how would you describe that? So you always have to start on north, south, east, or west. So up, down, left, or right. So I'm going to start here and then go to the vector. So that would be 53.13 degrees. That would be what? You're going down this way, so it'd be south of west. That would be your direction. Okay? Now, some of you may be looking at this one or even this one and saying, well, if this is my vector here, and I'll draw it in red, can I make the right triangle right here and put that there? Sure you can. This would be 40, this would be 30, right? And you're going to get the same exact triangle. It's just reciprocated over the vector. So you can do it that way as well. All right? I know that's a lot there, but you can do it. Some of you also maybe look, one thing I didn't point out that I'll do right now, some of you may be looking at this. Notice that I didn't ask for the component form. Some of you are saying, well, wait a minute, Mr. Scullin, you said if I went to the left, that should be a -30, and if I go down, that should be a -40. You're right, but since we're talking about distance with vectors, these are positive values. But if I'm asking you for this coordinate, that would be -30, comma -40. That point right there would be -30 to the left, x value, down -40. You would have to write component form that way. So just be careful with that. That gets a little tricky sometimes. But other than that, again, this is all review. Your assignment actually is a lot of the problems I took straight from what I do and teach in geometry. So hopefully you recall some of this information. But as always, if you have questions, I'll be happy to help you out, okay? Take care.